attached to the and forced to this magnet. That is the problem. Okay, so before that we considered and the no load condition and the load condition. And the no load condition is here. This line is no load condition, right? And oh my God, it's a little bit. This is the number is changed, right? Right. And this is a load condition is a safe. Sorry. Okay, right. This is right. This is 100%. And the 7.1 kilonewton it is, and attached to this. You can see the some of the animation. Okay, this is the no load conditions, and the rotor is even the rotor is rotated, just in this slightly, and this and it is moved by because of the sun and current. There is some, and you know, and the eddy current is happening, so slightly the some force is generated here. However, in case of the load condition, much of the force and generated. You can see peg iron, and it is almost the same. However, you can see that this and the tangential direction and the force is more than 70 kilonewton, and this support can support this an ASSS coil or not. That is the main point. Even though maintain big temperature curve, and between this and this approximately close to the more than 250 and the Kelvin and temperature gap is generated, and that is a very strong and tough the target of our and not only our research target but also most of and the wind turbine. They have to overcome such a high and torque. Okay, so we made a very very simple and evaluation system and performance evaluation system, and so we can cut like this, okay, and then we send here this data, and we send some current, and with the maybe maximum load condition, the current which is the same with the maximum load condition, then maybe the force between this and this is almost the same, and torque will be generated. So we designed this data like this. This is one, and this is the state condition. UVW is connected with different DC current sources, and then here is superconducting coils, coil 1, 2, 3, and they're connected in series, and then it is send field current sources like this. Okay, and after analysis using FEM and also using some handle calculation, and we can realize that the real machine, even though this real machine is not real, just on the simulation, however, and the performance evaluation system, the almost the tangential force is almost the same. The error is less than 0.02 percentages, and also output power is almost the same. Power is not generated, just to be considered. Okay, it is very important point of the graphs. You can see the maximum torque and this maximum force, tangential force, is 72 kilonewton, and at that time, and current ABC and the 1,040 is 790, and also not minus current, and the direction is different, right? And different direction in the 573, and different direction and the reverse direction of the 900 and the 913 ampere. And if we send and such a current to the sorry about that. Oh my God, too much. Send to the maybe this, and this is sources, then we could generate the same and the forces. That is the idea. So finally, and okay, and considering the real and ASSS generator, and then test the system, almost the same. So, and okay, you can see, you have seen already this animation before, and the load condition and the load condition. It is like this. However, in case of the past, we don't have money, so we didn't apply. We will not apply ASSS sources, and we don't have enough money, so the state commission is, state cannot and withstand with the ASSS sources. Now just only they can withstand DC sources only. In case of the DC sources, maybe the maximum and the forces for stress and displacement is almost the same, like this. So finally, and no loading condition, no problem, no current standing, and no loading condition. And if we send the current like that before, and one slide before, and then we can make this almost the same and conditions of the strong force. So maybe this and the test and will be occur and within 2020, so within 1 year. Maybe next year, January, February, also continuously we will test one another. Exactly, I don't know, maybe one more year we need. Almost we bought and this system without ASSS coil. And ASSS coil is just only 1 megawatt already. Maybe one month later we will maybe move to our experiment place. And then the state is we already bought, and then other frame is already bought. And also this cooling system will be almost the same with the real cooling system of and the designed ASSS 10 megawatt wind turbine too. And also power supply, and then the control monitoring system in here, and we can maybe see the results of the ASSS magnet will withstand even the very high torque or not. That is very important. If we overcome and such the circumstances, then maybe more than 10 megawatt wind turbine. Not only this way, but also another way it existed, I'm sure that. I don't want to emphasize our system is can cover all kinds of ASSS wind turbine. No, I don't say. I cannot say. And there is another way to make wind turbine more than 10 megawatts using the superconducting technology, but just only the well-known and wind turbine of the superconductivity, and it is like this way. We can test and the ASSS coil like this with these systems. Okay, so this is a dimension, and like this, and approximately, and more than 6 meter and 6 meter and 5 feet, and the system. So maybe next year, empty is this year, next year, right? Next year, maybe next next year, November in Antioch. At that time, maybe I hope and introduce this result, and then maybe we can get the results and from this. Then not only the wind turbine, but also other kinds of the rotating machines, and HTS and magnesium diboride and whatever, and rotating machine, and in order to and maybe test at a very high torque and machine, then we can test with this machine, I'm sure. So, and so this is configuration, and this is a little bit talk about cooling system, and here, and there is a cooling, maybe. This is a helium gas, right? And helium gas and circulation system connected to that. This is just on the behind of the machine. It is connected to to maintain less than the 30 Kelvin. Okay, and this is a cross section of the machine, and here the stator is located here, and this is the rotor and magnet, and so we will put close to this and the stator, then we can understand. And in the middle of the magnets and maybe 72 and the kilonewton. And so even though we apply the 3 magnets, however, the result is very similar with the 2 magnets and among the 40 force of the ASSS wind generator. this. It is moving the move, same force will be generated like this. There is some movie, and everybody already seen these movies so many times, and so I tried on it, but there is some rest of the time I didn't. And this is done by, and so some, and Google. So this is cross section, and the state and rotor, and this is a cooling system, just as you have seen before. And the 40 modules coil and connected. This is color is the temperature same, right? But the color is white, changing the blue and red. Anyhow, and then we cut and the 3 holes like this, and you can make this and the machine like this. And the stator, and finally, and because why is strong stainless steel and very strong and the frame is required because strong torque, and so we need very strong maybe and stainless steel and frame is required. So we send DC current in series. Then we send AC current, however, is impossible. So it is a DC and some fixed energy for its poster. So finally, like this. Thank you so much for your attention.
Thank you very much for that nice overview of generator. Any questions?
Very sorry about that.
Or in the conventional type generators, is there simulations of the force?
Yeah, it is. They don't need to require such a high torque, and we go less than that, and they don't need. And also, in case of current, maybe it's directly attached to the water, so they can overcome such a high torque load. But in case of HS coil, and we have to maybe avoid from the 300 Kelvin from the water, so we need some very and high resistivity of the thermal conduction and the supporter, and so we cannot overcome such a high torque. I don't know exactly, so we need test before going to the reality.
The tolerance against high torque may different the architecture of the fixed structure.
Yes, it's different.
Any other question? Okay. Students want to retire.
Yeah, we're very tired. Yeah.
So if not, let's thank Professor Park again.
Thank you.
So let's take a 15 minutes break.